Good day, everyone. Thank you for joining and welcome to today's webinar on demystifying Scope 3 emissions calculation methods. My name is Pranav Joseph, and I'm delighted to be here with you to explore this subject. So today our goal is to break down the complexities of Scope 3 emissions, the calculation methods, into understandable and actionable insights that you can apply within your organization. So we'll explore different methods and their applications and how they can help in creating a comprehensive greenhouse gas inventory. So with that, let's move on to some housekeeping details. So all participants except for the speakers are muted to avoid any disruption during the presentation. So this session is being recorded and recordings will be shared with you afterwards. So we'll also be conducting a survey during the webinar. So your feedback is invaluable, and completing the survey will provide you with access to additional resources that explain today's topics in greater detail. So lastly, if you have any questions or comments, please feel free to use the comment section, or you can email us at complaints@apengineering.com. So we'll do our best to address your queries as soon as possible. Introducing myself, I'm Pranav Joseph, a senior engineer regulatory compliance. So I've been working at the AP Engineering for the past 3 years. So throughout my time here, I've been deeply involved in regulatory compliance and sustainability activities. So joining me today is Riaz, our project lead in regulatory compliance. So together, we'll be walking you through the Scope 3 emissions calculation methods and helping to clarify these complex yet essential aspects of environmental responsibility. Introducing AP Engineering. With over 20 years of experience, we operate globally in US, European region, and Asia Pacific regions. We are ISO 27001, 9001 certified, and also DISAX certified. Over 350 plus customers. Services include compliance, engineering, sourcing, and software solutions. We offer tools for regulatory compliance and turnkey solutions, and much more. So we'll move into today's agenda. So we'll start with a quick refresher on Scope 1, 2, and 3 emissions to ensure that everyone is on the same page. And next, we'll take a closer look at Scope 3 emissions, breaking them down into upstream and downstream categories. And after that, we'll discuss various challenges that organizations face when trying to calculate the Scope 3 emissions, including the data types and the data availabilities. And finally, we'll explore the different methods available for calculating Scope 3 emissions across various categories, providing practical insights and examples along the way. So let's begin by revising the basics of greenhouse emissions, which are categorized into 3 scopes, starting from Scope 1. So these are direct emissions. So Scope 1 emissions are direct greenhouse gas emissions from the sources owned or controlled by directly the reporting company. So these emissions are directly generated by company's operation. Examples, the on-site combustions. So the emissions from burning fossil fuels like natural gases in boilers or furnaces, and company-owned vehicles. So the emissions from the fuel combustions in the company-owned or leased vehicles, or the vehicles that are under the direct control of the reporting company, and the manufacturing processes. So the emissions from chemical reactions during the productions, for example, the cement manufacturing, or during the metal smelting. So these are the emissions that the company has the most control over and can directly measure. So moving to Scope 2 emissions. So these are the indirect emissions from the energy. So in the indirect greenhouse emissions from the consumption of the purchased electricity, the steam, heat, or the cooling. So these emissions are produced outside the company, but still the result from the company's energy use. The examples include the purchased electricity, so the emissions from the electricity bought from the grid, to the power operations, lightings, or in equipments, and purchase steam or heat. These are the emissions from steam or heat that are purchased from an external provider for industrial processes or heating or cooling systems. The key point here is the scope 2 emissions are tied to companies' energy consumption, but it occurs off-site. So these are easier to measure due to their direct link to energy purchases. And coming to scope 3 emissions, so these are the indirect emissions from our value chain. So these scope 3 emissions includes all the indirect greenhouse gas emissions within the company's value chain, except for which we spoke in scope 2. So these emissions occur from the activities not directly owned or controlled by the company, but linked to both the upstream, which will be starting from the purchasing goods to the waste generation of the products, and the downstream, which will be the aftermarket, which will be after the product leaves the company till its end of life uses. So we'll have a small poll here. Kindly take 30 seconds to complete the poll. Then we'll continue from here. Thank you. Hope everyone has completed the poll. So we'll come back into the topic. So as I said before, the scope 3 emissions are divided into two types of emissions, the upstream and the downstream emissions. So the upstream emissions are the emissions from the company's suppliers or the other supply chain entities. So the GHG protocol has separated these upstream and downstream emissions into 15 categories. So we'll look at the first 8 categories, which comes under the upstream emissions. The purchase goods and services. These are the emissions from the production and transport of the goods and service we buy. Example, the emissions from purchasing steel or paper used in our manufacturing process. And the capital goods. So these are the emissions from producing our long-term assets, like the machinery and buildings we use. And fuel and energy related activities. So these are not included in the scope 1 or scope 2. So these are the emissions from extracting and producing and transporting the fuels that we purchase and use in our production activities. And upstream transportation and distribution. So these are the emissions from transporting goods that we purchase, especially through the third-party logistics. So the shipping of raw materials to our facilities are some of the examples for this category. Waste generated in operations. So these are the emissions from disposing of the waste from our operations. Business travel. So the emissions from the employee commuting to business related activities. The flight or rental cars used for these business trips and the emission related to that comes under this category. And employee commuting. So emission from employees commuting to work. So driving their personal cars or using personal transit, and the emissions related to that will be covered in this employee commuting category. And finally, the upstream lease assets. So the emissions from the leased assets that were not included in scope 1 and 2 will come under this scope 3 upstream emission category. So the energy we use in the leased office spaces are some of the example of this upstream emission. So let's move on to the downstream emissions. So these are the emissions related to our products after they leave our control. So these are the emissions occurring after the product leaves the company's control. So the categories are given below. So starting from the downstream transportation and distribution. So the emissions from shipping of products to our customers or retailers. So the trucking products to our retail stores are some of the example. And next, the processing of sold products. So emission from further processing or products by other companies using it as an intermediate product. So the emission from the processing comes under this processing of sold products category. Example, processing of steel into any car parts or any heavy automatic vehicle parts. Use of sold products. So the emission from using our products over their entire lifetime. Example, the fuel consumption of any sold cars. So this is an example of this category. End of life treatment of sold products. The emissions from disposing of products and the recycling and incinerating of the products will come under this end of life treatment of sold products category. And similarly, like upstream lease assets, the downstream lease assets are the assets we own but lease to others. So example, the energy usage of our leased machineries and the emissions are related to these downstream emissions. And finally, the franchises and investments. The emission from franchised operations that will not be covered in scope 1 and 2 will be covered here in scope 3. The emission from a franchised restaurant chain or any food trucks will be some of the example here. And the emissions from the companies or other entities that we invest in are the emissions from a company that we have equity in. So this will come under the investment category. So scope 3 emissions are the most challenging to quantify due to their indirect nature, but they often represent the largest share of companies' carbon footprint. So understanding these differences between these scopes is crucial for accurately assessing and managing your company's carbon footprint. So with this foundation, we'll go further into scope 3 emissions. These challenges in scope 3 emission calculations. So we'll start with the types of data. So we have two types of data here, the primary and secondary data. So the primary data includes the data provided by the suppliers or others within the company's supply value chain. So it is specific to the activities being measured and is typically more accurate. The secondary data are the industrial average data from sources like published databases, the government statistics, and the literature studies and the industrial associations. So it also encompasses the financial data, the proxy, and other generic data. So proxy data is a type of a secondary data where the data from one activity is used to estimate the emissions for another similar activity in the value chain. Although useful, it lacks the specificity of the primary data. The secondary data sources included in the calculations are just examples and not an exhaustive list. So the GHE protocol website has the comprehensive list of the secondary data sources as a link given here. There's some of the challenges in collecting the data for our scope 3 emission calculations are listed below. So we'll look into one at a time. So first one will be the lack of direct control over the data. So the companies may often rely on external entities like suppliers and other customers for data. So this can lead to incomplete or inaccurate data, complicating our scope 3 emission calculations. The quality and the completeness of the data can vary, so leading to inaccuracies. The solution would be implementing a supplier engagement programs, like establishing a strong relationship with the suppliers and emphasizing the importance of accurate emissions reporting. So the company can improve data quality, providing training tools and incentives to the suppliers and incorporating emission reporting requirements into the contracts. So this can enhance compliance. Secondly, the inconsistent data reporting. Suppliers may use different methodologies or standards to report their emissions. So this may also lead to inconsistencies. So this inconsistency make it difficult to compile and compare the information across different sources. So adopting a standardized reporting framework would provide consistency. These companies can also develop their own guidelines for the suppliers to follow. Estimation and proxy data. When the actual data is unavailable, so companies may need to use and rely on the estimation techniques or the proxy data. So this introduces uncertainty and affects the accuracy of scope 3 emission calculations. So utilizing the industry specific emission factors in the absence of the direct data, the companies can use these industry specific emission factors or develop their own based on similar operations. So collaborating with the industry groups or research organizations can help refining these estimates. The confidentiality concerns. So suppliers may be reluctant to share their detailed emission data due to confidentiality or competitive concerns. So data gaps may force company to rely on less accurate data or make assumptions. So establishing a data sharing agreements can protect the confidentiality while allowing access to the necessary estimation data. So clearly specifying how the data will be used and shared can help the suppliers feel secure in providing detailed information. So these challenges highlights complexities involved in scope 3 emissions. So, but with strategic approaches, companies can overcome these hurdles and improve the accuracy and the reliability of their emission data. So we'll explore the various calculation methods available, ranging from supply-specific method to spend-based approaches. So each method has its own advantage, limitation, and ideal use cases. So it's important to know when and how to apply them. So we'll start with the upstream category, emissions category 1, the purchased goods and service. So this method is most precise, relying on emission data provided directly by the supplier. The formula for estimating this emission would be the summation of the activity data multiplied by the supplier specific emission factor, which is provided by the supplier. So for example, if you purchase 1000 kgs of steel with the supply specific emission factor of 2 kgs of carbon dioxide emitted per kg of the steel, so the emission factor would be the summation of these two, which would be 2000 kgs of carbon dioxide emitted. So the activity data required for this method would be the quantity of the goods purchased, and the emission factors required is the supply specific, the cradle to gate emission factors of the purchased goods or services. The cradle to gate emission factor is the combination of the emission factor starting from the raw materials to the transportation to the waste management of the production of the particular product. So moving to hybrid method, this hybrid method combines the supply specific data with the process based emissions. So the formula would be the activity data multiplied by the available scope 1 and 2 emission factor of the company which produces the steel, and also the process based emission factors, which also includes transportation and other activities that the company may be involved in. So if you purchase 1000 kgs of steel with the scope 1 and 2 emission factors of 1.5 kgs of carbon dioxide emitted per kg of steel produced, and also the other combinations of process based emission, which is 0.5 kgs of carbon dioxide emitted per kg of steel production. So the emission would be 2000 kg with the formula applied. So similar to the previous method, the activity data required will be the quantity of the goods purchased. And for the scope 1 and 2 and the other process-based emission, the financial data and the transport data will be the activity required. So emission factor is similar, the cradle to gate emission factor of that steel. Moving to the third method. So here we use industry-wide average emission factor. So it will make it less precise but easier to apply. For example, if you are using an average factor of 1.5 kg of carbon dioxide emitted in the production of 1,800 kgs of the steel, 1,000 kgs of the steel, the emission would be the activity data multiplied by the average emission factor. So these average emission factors are the secondary data that we have mentioned previously. So these are the same. These will be calculated based on similar activities that happened across industries. So they are handle the average emission factors for this for all kind of manufacturing and the materials will be available in that secondary data sites. So the activity data required here will be the same as the previous, the quantity of purchased goods and the emission factors, the cradle to gate emission factors, which are the average here from the secondary sources. Finally, the spend-based method. So this method simplifies calculation by using the financial data, so which is particularly useful when the physical activity of the and the other data is unavailable. So for example, spending $5,000 on steel, so which has an emission factor of 0.4 kgs of carbon dioxide emitted per monetary value. So here in this case, the emission will be 2000 kgs of carbon dioxide emitted. Here the activity data is the financial spend on the goods and the emission factor for the economic value. So these are also the secondary data for economic value that companies uses in case of the absence of the other data. So while using supply specific methods that provides high accuracy and the average data and the spend methods are more accessible when the specific data is lacking. So the hybrid method offers a more balanced approach. So we move to the second category, the capital goods. So it is similar to the purchase goods method. So the supply specific method is also relies on the supply specific data. So if you are buying companies buying a machinery worth 2000 kgs and the supply is given a supply specific emission factor of 3 kgs of carbon dioxide has been emitted for the kg of the machinery produced. So the emission here would be the 6000 kgs of carbon dioxide emitted. So the activity data will be the quantity of the capital goods purchased and the specific emission factor given by the supplier would be the emission factor applied. So in the hybrid method, the combining scope 1 and 2 methods and other process-based emissions, as we saw in the previous purchase goods method. So this is a similar one. We use scope 1 and 2 emission factors of that machinery and other process emissions that are involved in during the production of that particular machinery. So the emission factor required here will be the cradle to gate emission factors of the machinery. Yeah, I said before, the average product method and average spend method. So these both uses the secondary data using the industrial average method and the industrial average factors. If you are purchasing a machinery worth 2000 kgs, this has an average emission factor of 2.48 kgs of carbon dioxide emitted per kg of the production. So these are all the example values. So these are not actual values. These are just for example. So the activity data required for this will be the quantity, the capital goods purchased, and the cradle to gate emission factors per unit value will be the emission factor. And similarly for the spend-based method, the amount of monetary value spent on the machinery and the emission factor per monetary value will be the required accurate data and the emission factors. Just like purchase goods, the supply specific method offers the most accurate results, while the other method is more practical but might lack precision. The fuel and energy related activities, these are not included in scope 1 or 2. So this includes the activity data and emission factors from the energy production company or the energy grid that we purchase electricity from. So if you're purchasing 5,000 kilowatts of electricity with a supply specific emission factor given by the grid, that is 0.5 kgs of carbon dioxide that is emitted for per kilowatt hours of the electricity produced. So for these 5,000 kilowatts of electricity, the emission factor is 2,500 kgs of carbon dioxide emitted. So the activity data required is the total quantity of the fuel or the energy purchased, and the emission factor will be the fuel provider specific emission factor, which will be the cradle to gate information from extracting and transportation and of the fuels per unit of fuel consumed by the reporting company. So the average data method. So it is in a similar pattern to the other two categories we saw. While the average data offers ease of use when the specific data isn't available. The same formula, but we use industrial average emission factors for the electricity per unit of consumption. So moving to upstream transportation and distribution. So these also have three types of methods: fuel-based, distance-based, and spin-based. So if your transportation consumes 1,000 liters of diesel with an emission factor of 2.68 kgs of carbon dioxide emitted per liter of the fuel, the summation would be the fuel consumption multiplied by a emission factor, which is 2,680 in this case. So the activity data required will be the quantity of the fuel consumed, and the emission factor is expressed in units of emission per energy consumed. The distance based method. This method uses the distance traveled and the weights of goods and the emission factor. So, for example, transporting at 2,000 kgs of goods over 500 kilometer. So this has an emission factor of 0.02 kilograms of carbon dioxide emitted per kg kilometer. So the summation of these three will give us the emission factor, which is 20,000 kgs of carbon dioxide emitted in this case. So here the activity data required will be the distance traveled and the weights of the goods. So these emission factors include the emission factor by the mode of transport, by the different types of transport the company uses to transport the raw material to the industry. And the final method, the spend-based method, similar to other categories, this method uses the financial data and the emission factor per spent economic value. So if you're spending $3,000 on the transportation, so with an emission factor of 0.5 kgs of carbon dioxide emitted per dollar. So these are all the secondary emission factors that we use from the secondary databases. So the fuel-based method is most accurate when the direct fuel data is available. So while the distance and the spend-based methods offer alternatives when fuel data is not available. Business travel. So if the business travel consumes 2,000 liters of the fuel with an emission factor of 2.5 kgs of carbon dioxide per liter, fuel consumed. So the emission factor here will be the fuel consumption into the emission factor, which will be 5000 kgs in this case. So here the activity data required is fuel consumption, and the emission factor will be the life cycle fuel emission factor is expressed per unit of the energy consumed of the fuel. So the second method is the distance-based method. So here the emissions are calculated by multiplying the distance traveled with the emission. It's solved by the emission factor per kilometer. For instance, if the employee is traveling 10,000 kilometers by air, and the emission factor is 0.5 kgs of carbon dioxide emitted, so the emissions will be total 1,500 kgs of carbon dioxide emitted. So this approach is straightforward when you have the accurate distance data. So here the emission factor will be the same as before. The emission factor represents the kilograms of carbon dioxide emitted per kilometer travel for each mode of transport. So this employee commuting would be same as previous method, fuel based and the distance based, the amount of fuel consumed and the distance traveled by. So double using of the data should be watched carefully while calculating. There should be no confusion between the business travel and the employee commuting data. So one data should not be used again mistakenly. That would cause a huge difference in the scope 3 emission calculations. So we'll move on to the next and final one in upstream category. So upstream leased assets and their emission. So these are also categorized into three specific methods: asset specific, lease specific, and the average data method. So asset specific method is if you're leasing an asset that consumes at 10,000 kilowatts of electricity with an asset specific emission factor, which would be the fuel used for the generators or the electricity or the steam or the heating or cooling of that specific asset, and their emission factor. In this case, it is 0.4 kgs of carbon dioxide emitted per kilowatts hours of the electricity consumed. So here the emission factor is the asset specific emission factor for the energy sources, whether it is fuel based or electricity based. So the leaser specific method. So this is similar to the asset specific method. Here we also incorporate the area leased in the leaser specific emission factor, the area which is the lease to the leaser, and the emission factor specific to that leased area will be the special emission factor for this topic. So the activity data would be the leases, fuel use, the electricity, and the area leased. So these asset specific emission factors are the emission factors per unit value of the consumption of the fuel or the electricity. So average data method, it is similar to what we saw in previous categories. We are using the industrial average method for the assets. So here the industrial average emission factor by asset type or the lease types will be available in the secondary data websites. So we are incorporating the average emission factors from the third-party sources here. So moving to downstream emissions. So this also is same as the upstream transportation distribution. So the fuel-based method requires the amount of fuel consumed, and the formula is same as previous. So the activity data required will be the amount of fuel consumed and the emission factor of the fuel. and in distance-based method. So here also the activity data required will be the distance traveled by the transportation and the weights of the goods that has been carried, and the emission factor is required for distance and weight. And the spend-based method. This method uses yes, the financial data to estimate emission. So this is also same as the previous spend-based methods. So here we require the exact financial spend on the transportation and the emission factor per monetary unit spent. So the fuel-based methods are more accurate when the fuel data is available. So as I said before, the distance-based methods work well when fuel data is not available. So moving to the processing of sold products. So this process involves transforming or processing our sold intermediate products into a usable state of the final product subsequent to sale by the reporting company. So this site-specific method uses the process involved in transforming our product into a final product by the consumer company. So the fuel used and the fuel emission factor, electricity, the refrigerations, and the other process emissions are and their factors are used in this calculation. So say that a product uses 2000 liters of fuel at the rate of 3000 kgs of carbon dioxide emitted per liter during that intermediate transition. So that would be 6000 kgs of carbon dioxide emitted. Similarly, the electricity, the refrigerant, and the process emission, the emission occurring during the transition process of the product into an intermediate product, and the related emission factor of that process emission. And the total emission would be sum of all these emissions. These are not in list, not in order. This may vary. This is for example. Whichever the fuel use, if in some cases the refrigerant or the waste are not included in the calculations. So wherever required, the emission factors and the activity data is included. So the activity data for this activity will be the fuel and electricity and refrigerant data and respective emissions. The average data method. So these are the secondary data source that we use. Here the quantity of the products processed is activity data required, and the industrial average emission factor of that particular product will be used to calculate this emission. So use of the sold products. So this categorized into two, direct use phase and the indirect use phase. So direct use phase is the products that directly consume energy during use. So the formula would be the lifetime uses into the number of units sold multiplied by the emission factors, which will be the fuel, electricity, or the refrigerant leakage per use. So if 500 units are sold, so each used 100 times, consuming 200 kilowatts or 2 kilowatts of electricity, and other listed here. So each of them will give us a emission factor as given below, using the formula the lifetime uses and the number of units sold by the emission factors. So I said before, these three are not mandatory, but based upon the nature of the product, the direct use phase will be calculated in this method. So here the activity data required will be the product lifetime uses, the number of units sold, and the electricity or fuel spent per product, and refrigerant leakage if in case. So the emission factor required will be the emission factors of the respective fuels or electricity or the refrigerants. The second method here is indirect use phase. So the indirect use phase, one of the example for the indirect use phase is selling of, say in food industry, selling a packaged food material. The lifetime use of the product into the percentage use in scenario, the number of scenarios that the product is being used and the units sold multiplied by the emission factors. Say if the food product is being used for roasting 30% of the time, so that will consume 2 kilowatts of fuel. And if the product is used boiled, 50% of the times the product is boiled, so the electricity consumed and the emission factors are mentioned. Or if the food product is microwaved 20% of the time, so leading it to 0.05 kgs of refrigerant leakage and the global warming potential of 1300 kgs of carbon dioxide emitted. So the addition of these three scenarios will give us a total emissions of the carbon dioxide in this indirect use phase of this product. So this approach counts for different use scenarios and their frequencies and energy consumed to estimate total indirect emissions. So here also the indirect in indirect use phase, the average data required would be the average number of uses, the average number of use scenarios as mentioned above, like roasting, boiling, or microwaving. So different kind of scenarios that our products are being used and the fuel consumed in those scenarios. So the emission factors are for fuel and electricity and refrigerants in terms of carbon dioxide emitted per kilowatts of electricity or the kg of fuel. The 12th category will be the end of life treatment of the sold products. So this method calculates the emission based on the disposal method and the material type of the products. So if a plastic waste is treated with an emission factor of 2 kg of carbon dioxide emitted, and it also has a 300 kg of metal waste with an emission factor of 0.8. So the emission would be the sum of both these multiplied factors, which is 1240 kgs of carbon dioxide emitted in this case. So here the activity data required will be the quantity of waste per waste type, the plastic waste or metal waste, and the emission factor will be the average waste treatment specific emission factor. So these emission factors are provided by the waste treatment company for the waste disposal type. The downstream lease assets are completely similar to the upstream lease asset, asset specific method, lease specific method, and the spend based method. So we'll move into the franchises category. Here the franchise category has two methods to calculate the emission. First with the franchise specific method and the average data method. So if a franchise is operating at an activity level of they're producing 10,000 units of the product, and the franchise specific emission factor, the franchise specific emission factor would be the scope 1 and 2, the emission factor of the franchise. So in some cases scope 3 emission factor of that franchise may also be required to be included here. So the emission would be the number of units of the product into the emission factor, which is 3000 kgs of carbon dioxide emitted in this case. So the activity data required will be the quantity, the units of the product, the scope 1 and 2 emission factors per franchise. So the emission factor would be the site or the specific emission factors for the energy sources that the franchise uses per unit consumption of whether electricity or the fuel. The franchise average data method is like other categories. We use the industrial average emission factor here and the activity level of that franchised outlet. So moving to the final method, final category, which is the investment category. So it also has two methods, the investment specific method and the project specific method. So this includes the emission of the scope 1 and 2 emissions of the equity investment into the share of the equity. So let's consider a scenario where the total scope 1 and 2 emission of the company you have invested is 500,000 kgs of carbon dioxide, and your share of equity is in the company is 20%. So the emission would be the total emission, scope 1 and 2 emission of the company into their equity share. So it will be 100,000 kgs of carbon dioxide emitted in this case. So the activity required is simple as the investment data, and the emission factor required will be the scope 1 and 2 emission factor of that particular site. The project specific method, same as before. So here we'll consider a scenario where the scope 1 and 2 emission of the industry for the reporting area is 400,000 kgs of carbon dioxide, and your share for the total project is 30%. So the emission would be the emission factor, emission of that particular product into the your share of the total project, which is 30% here, which will give us 120,000 kgs of carbon dioxide emitted. So here the activity data required is your share of the total project cost, and the emission factor is scope 1 and 2 emission factor of that particular industry. So we covered all the calculation methods of the 15 categories included in upstream and downstream categories. So in this webinar, we've looked deep into the concept of scope 3 emissions and their categories and the methods for calculating them. And scope 3 emissions are very crucial because they often represent the largest portion of an organization's total greenhouse gas emission. So understanding and measuring these emissions is essential for gaining a comprehensive view of the organization's environmental impact. So by accurately calculating the scope 3 emissions, organization can identify significant opportunities to reduce their carbon footprint beyond their direct operations. So this is not only helping in mitigating climate change, but also enhances the sustainability efforts across the entire supply chain. So while measuring the scope 3 emissions, this can be complex and challenging due to their need for extensive data collection and various other factors. So the benefit for outweigh these challenges. So accurate measurements leads to the increased transparency, the better risk management, and alignment with the global climate goals. So it also meets stakeholders' expectations and drives innovation within the organization. So in conclusion, addressing scope 3 emissions is a critical component of any effective greenhouse gas reduction strategy, offering a long-term benefit for both the organization and the planet. Thank you for joining the webinar and listening. So if you have any questions, you can email us at complaints@apengineering.com or